and g is differentiable at x, then this composite function f of g of x is differentiable at x. And f prime, or I'm sorry, f of g prime of x, or f prime of is equal to f prime of g of x times g prime of x. Other words, it's the derivative of the outside function evaluated at the inside function times the derivative of the inside function. This is the chain. This part here is referred to as the chain. So it's a good function. So this one here is the function. So I'm going to let u equal 5t minus 3. So u prime is going to be 5. And then now I take this out and put in u, so I have s of u equals sine of u. So s prime of u is going to be derivative cosine of u. So my derivative is going to end up being u prime times s prime of u. There's a derivative of the outside, evaluated at the inside, times the derivative of the inside. So v of t is equal to 5 times cosine of u, but u is 5t minus 3. And there's our derivative. So again, it's just breaking it out. What is it on the inside? 5t minus 3, its derivative. And now take this out, so this is u. So now we have s of u. S of u is sine of u. Its derivative is cosine of u, and then the derivative altogether, so the dx, or in this case dt, is going to be u prime times s prime of u. Let's try this one again. Okay, here's my u value. So I have u equaling t squared plus 1, so u prime equals 2t. X of t, or x of u, is equal to cosine at u, and the derivative of cosine, so x prime at u, is negative sine of u. And so our derivative with respect to t in the end is going to be u prime times x prime of u. Again, go back to that first day. Derivative of the outside, evaluated at the inside, times the derivative of the inside. So x of t, so x prime at t is equal to 2t times negative sine of u. Let's go ahead and put u in there. But you got to make sure you put that substitution in there. So this is negative 2t sine, and my u value is t squared plus 1. So there's x prime at t. And if you're going where this negative comes up, right here. So you can see that the inside is never going to change. You're just going to do the derivative of it. Okay, let's try another one. U is equal to pi over 2 minus 3t. So u prime is negative t. Oops, I lied. Negative 3. Negative 3. What did I hit? The wrong thing. Negative 3. And then s of u, because this is now u, is equal to cosine of u, and s prime of u would be negative sine of u. And our derivative with respect to t would be u prime times, s prime of u. So v of t equals negative 3 times negative sine of u. Two negatives make a positive, so we get 3 sine, and my u value is pi over 2 minus 3t. Now you could use s prime at t, but since we know it's a position function, we know they gave us position with s of t, so I just went to the velocity function. Okay, now for some of you guys, you're going to catch on very, very quickly on this one here. Others will have to continue writing that out. It sometimes helps to think about the chain rule this way. Y equals f of g of x, then dy dx equals f prime of f prime at g of x times g prime of x. In other words, differentiate the outside function of f and evaluate it at the inside function g of x. Left alone, don't touch it. Then multiply it by the derivative of the inside function. So this one would probably be a little bit more helpful in class. But if I want to differentiate cosine of 3x to the 4th power minus 2 with respect to x, using the inside-outside rule, well, the derivative of the outside is going to be negative sine, evaluated on the inside, 3x to the 4th minus 2, times the derivative of the inside, which is going to be 12x cubed. So dy dx is equal to negative 12x cubed times sine of 3x to the 4th minus 2. Now this becomes difficult if you got a lot going on with your derivative, but when you don't have a lot going on, it's kind of quick and easy. You just do the derivative, keep this guy, and then do the derivative of this guy. Some people find it more helpful to do the derivative of the inside and then ignore it when you do the derivative of the outside. So let's try that one. Derivative of the inside is going to be 2x plus 1. Derivative of the outside, derivative of sine, cosine. Cosine of x squared plus x. And there is your derivative. Now you might find that to be a little bit easier and say, well, the derivative of the inside evaluated at the outside, derivative of the outside evaluated at the inside times the derivative of the inside. Just do the derivative of the inside times the derivative of the outside, and just don't forget this guy here. Don't forget the rest of them. Okay, let's try this one. One more. So, almost had that pause before the announcement went. All right, so this one here, y prime, derivative of the inside is going to be 1 plus, we can always do this one, square root of x is x to the 1/2 power, which is really going to be 1/2 x to the negative 1/2 power, or 1 over 2 square root of x. So 1 over 2 square root of x. So we did the derivative of the inside times the derivative of the outside. Well, the only thing we have is our power rule going on. So it's going to be times negative 2, times what's on the inside, x plus square root of x. Just don't forget to leave them there. So let's do a little cleanup on this guy. So y prime equals negative 2 times, oops, did you notice I forgot something here? Don't forget the negative 2 minus 1. 1 plus 1 over 2 radical x times x plus square root of x to the negative 3rd power. Now you can clean it up more by multiplying through, but I would only do that if I had to find the second derivative. But there's your derivative. Again, derivative of the inside, there it is, times the derivative of the outside, that's just the power rule, bringing down the negative 2. Pretend that guy's just x, and then just don't forget to subtract the 1. Okay, well that is the end of day 1. 10-minute video. I know if you guys sat down and watched it, it'd take you probably closer to 20 or 30 minutes. So let's just see how it goes. Good luck.